a seed grower way back when and was looking for information about how to grow seeds, how to do seed saving, how to do variety improvement, make varieties better, and came across some of Organic Seed Alliance's information back, whatever that was, the early 2000s. And, through a process, first I started contacting them, just wanting to get information. Hey, how do I grow this? How do I grow that? What should I? But then also, as I was working on the seed farm, I wanted to learn more about seeds, more about variety improvement, and started asking some of the folks at OSA at the time, where can I get more information? How can I learn this? And they sort of started steering me towards different schools and things like that I could be involved in. And so when I went back to school, I became more involved with OSA at the time. We worked on some participatory breeding projects where I worked with a farmer when I was in graduate school, improving some of their varieties, and also worked with OSA on that. And so after school, I went out to Washington, which is where their home base is, and was splitting my time working part time on this larger seed production farm and part time with them, and then been working with OSA ever since then. Kind of brought the work down here to California.
And so why the interest in seeds? Because you started out as a
Yeah,
biology major,
yeah,
right?
yeah,
How did the turn happen where you thought, "Okay, I'm interested in seeds and seed saving."
yeah. The first kind of twist in my life, I guess, was realizing that I loved science. I loved understanding how nature, trying to understand nature better. I also had previously been doing computer science in school, and just while I really enjoyed it in a lot of ways, just the future that I envisioned for myself sitting in front of a screen for the rest of my life just seemed a little bleak.
Kinda
And
sucks the fun out of it.
yeah, I mean, so I started thinking, what's something where I can do science and still get my hands dirty and be outside, and started thinking about agriculture and agricultural science broadly back when I was an undergrad. And then really kind of fell into it just flipping through. I had graduated my undergrad, did it at Humboldt State, and had after school looking for an opportunity. I'd been working on a farm. There's like the Bayside Community Park Farm. I'd been working on that while I was in school here, way back, in 2000, and was had graduated, was kind of thinking about the next steps, and had been flipping through one of these catalogs of places where you could apprentice, like in, Woof, like you could be able to work on working farms and learn from them. And just was looking through and seeing, what was interesting, and came across this farm in New Mexico that was called Jardín del Alma, and said, we grow food for our sustenance and for the farmers market, but we also grow all these seed crops of varieties that are, adapted to the southeast or the southwest, are ones that are really important to us. And that was the first time I'd ever heard of people who grew seeds and saved seeds, and that was part of their farm. And it just seemed like, wow, that's such an interesting, different part of the plant's life cycle, and a part, like a bigger part of the process that I never really thought about. And so I just kind of dove in. I, talked on the phone and then hopped on a Greyhound bus and spent 2 years out in New Mexico working with this incredible farm and wonderful family. And that was really where I found the passion for seed work. I think one of the things that really stuck with me when I was out there, I remember we were harvesting, I'd been spending the summer harvesting all these different seeds. In particular, I remember harvesting these tomatoes, this Cherokee purple variety. And, each week we'd harvest it and squeeze the seeds out, and you let the seeds ferment in order to process them and get all the seeds all clean. And at the end of the year, we had this um, Ziploc baggie full of tomato seed. And the farm owner had uh, collected maybe like 4 ounces of these seeds and separated them out for this larger tomato produce grower that lived closer to Albuquerque. And he came down and visited and was just so excited. He was like, "This is going to be able to plant 4 acres of our tomato crops this year." And just knowing like the care that we had all put into like choosing, like, okay, this is out of our patch. Like these are the best plants and the best fruits and the best seed. That all of that work, would was so important because that was going to impact how well this farmer in turn was able to grow their tomatoes and how those varieties would work for them and if it was, they were going to be disease free and vigorous plants. And I just could see as a seed grower this opportunity to have this really big impact on the farming community. And so that got me really excited. And also just the opportunity. So often we were working with different, we're working with varieties that had a lot of variation. And sometimes some plants would fail in the tough New Mexico heat or the winds, or the dry conditions. We'd only get to water basically every 3 weeks. We get access to this irrigation, and so some things made it, some things didn't. And I knew that in that process we were acting as forces of evolution and able to improve these varieties, strengthen them for these local, somewhat unique conditions. And so also being able to have this deeper connection and part of the food and plant life cycle that I didn't experience as much. I mean, I got to experience a little bit as just a produce grower, but when I started interacting with seeds, I got to feel just this deeper connection that was really exciting.
And are farmers normally the ones that are breeding for seeds like that? I thought I read a blog, it was a blog post by you, and it discussed how farmers aren't really the cultivators of seeds like they used to be. Now it's all schools, universities that are engineering these seeds and are holding on to them. Does that ring a bell? Is that true, would you say?
I mean, it's a mix. So I would say on one hand, obviously, so much of the varieties that we have today, the food that we eat today, all of that is built on the backs of thousands of years of farmers, gardeners, stewards of our seeds. So, so much of the improvement and adaptation and evolution that's happened in all of our varieties has been done by all of these generations. And that work continues and has continued unbroken in a lot of ways throughout the world. So if I think if we probably said, what percent of farmers globally save seed, it's probably a large percent. Here
What
in
about in the
Yes,
US?
here in the US, however, there had been this transition from farmers primarily saving their own seeds to, like there had been seed catalogs even back like in the 1800s, for example. But what would happen for a lot of seed catalogs is they would expect to kind of make one sale. Like they would be like the seed discoverers, right? They would say, "Hey, we found this new variety, and we're going to sell it to you." But they knew once the farmers got it, once they got that seed, that was probably the last time they'd sell to those farmers. And so that really started to change in the 30s with the invention of the development of creating hybrid seeds, ones where you would cross two different varieties basically together and then sell that first generation cross. And in that first generation, everything would look nice and uniform. But then if you tried to save that seed, you'd start to get a mix where some of them look like one of the original parents, some look like another one, some look like a mix in between. And so they weren't as reliable. And so that was this kind of biological form of protecting the seed company's intellectual property. And then on top of that, more and more legal forms of intellectual property started to develop. And all of that in combination with sort of the specialization and concentration that just happened more broadly in agriculture shifted things away in the US from farmers saving their own seed to primarily buying those seeds from companies. As far as who's kind of developing and improving those varieties, I would say right now we have an interesting mix. Definitely the bulk of the research, the bulk of the money that goes into research, the bulk of the money that goes into seed production and release, distribution, all of those things is in the hands of the big seed companies, kind of the big four that control, the majority of the seed market globally and in the US. There's also and kind of another trend that had happened is you had mentioned kind of our universities doing a lot of this work. They kind of at a certain point the agricultural universities had done a lot of the pioneering work on developing more what we call modern varieties, ones that might have really strong disease resistance packages, ones that would make use of some of that hybrid technology to create these uniform, highly productive varieties or varieties that would produce well in high input situations, as well as varieties that served farmers of all. I don't mean to disparage the work that they did because a lot of those public universities and the public university plant breeders did really have a service mindset of trying to serve the farming community, wherever they were located. And so, these different universities would develop varieties that were better for their regions and did a lot of really good work. As the seed companies kind of became more and more powerful and also invested more and more in their own research departments, they really made a push at the universities to say, what we need from you is we need your student pipeline. We need, you to train scientists that we can employ, and we need you to do kind of pre-breeding work. We don't want to have to spend the time of like starting with like a this wild tomato that's, a tiny, you know, tiny little green tomato fruit, but it might have this important source of resistance to a particular disease. We don't have to do the work of trying to take that and somehow get those genes all the way by many, many generations of crossing, have to get those into our modern varieties. You do all this, what they would call pre-breeding work, and we'll be the ones actually developing like the commercially viable varieties and selling those. And so there had been this split where a lot of the universities, both through company pressure, but also through kind of internal politics around always, a university always want to be doing something new and novel, and traditional plant breeding wasn't exciting enough. Started to shift away from plant breeding work towards more basic genetic research, genetic engineering research, some of this pre-breeding work, and not really necessarily serve the farming communities the way they had.
Well, there's more money in the genetic engineering, right? Can't you patent the seeds that you devise that way?
So that's a big part of it. So um, the way, and I don't, we should, we want to have our policy director on to, she would know all the exact dates and numbers, but essentially there are kind of a few different ways that intellectual property and seed works. And the very earliest development was around asexually producing things like flowers or apples, and there are things that are called plant patents that prevented people from being able to reproduce these clonally reproducing crops without some form of agreement with whoever had originally developed them. And that had been it for a while until, I think in the 70s, this law got passed through Congress called the Plant Variety Protection Act. And this you'll see if you flip through seed catalogs, you'll see on some varieties it says PVP on it. And that stands for Plant Variety Protection. That was the last law basically that Congress actually passed around plant intellectual property, saying that, and that one had been worked out with farmers and breeders to carve out some really important exemptions for that allowed first it allowed farmers to still save their own seed of those varieties. You couldn't commercialize if a variety had this kind of intellectual property, if it had a plant variety protection on it, you couldn't turn around and grow that seed and sell it, but you could save it for your own use. And it also allowed farmers and breeders to take those varieties, even if they were protected, and make crosses between them and other varieties and create new material. So it stopped those varieties from being these genetic dead ends. Um,
Before that law and
yeah,
those allowances, if
yeah,
you bought those seeds and you grew it,
yeah. You
could
could
you couldn't save the seeds and regrow it?
no, you could do whatever you want
Oh, you
before
can.
that
So
law.
once you have the
Yeah,
seeds,
yeah,
you're good. You don't need to
right,
buy more seeds.
right, exactly. If you were in a place that had the right kind of climate and conditions to grow them. So this was the first pretty big restriction that happened in the 70s. Then in the 80s, 90s, and up till today, there have been a series of court decisions, primarily the Supreme Court, that This was never part of the original um, legislature. This wasn't something that Congress authorized, and in fact, Congress very explicitly kind of uh, put in these exceptions into the only law that they had had, saying that yes, that we want to encourage some degree of intellectual property for good or ill, but we still want to make sure farmers can save their own seed and that people can keep breeding these varieties. But um, the regular kind of forms of patents, the patents that you have on, on toasters or microphones or whatever, don't apply to living materials. So the Supreme Court came in and starting with genetic engineering, though this is really expanded out, started to have rulings that said that life can be patented using traditional patents. And these traditional patents can allow you can they can be very broad and they can be very restrictive so that you can't save seed of this variety even for your own use. You can't even necessarily like collect data on this variety without permission. You can't be able to make new crosses with a particular variety. Sometimes it's even really broad genetic traits, not necessarily genetically engineered traits, but things like heat tolerant broccoli or lettuce that has red inner leaves. Those that but so all of that's kind of sort of where we're at today is that these plant patents of these traditional utility patents is what they're called have been are being used by everyone to restrict seeds really broadly. But it started with kind of the first toehold, the first wedge between what Congress had originally said was that there should be these exceptions for seed saving, and where we're at today was, as you're alluding to, in GMO crops and genetically engineered crops. That the courts, not Congress, said that this genetic engineering, this is a kind of novel inventions. These should be patentable. And that ability to patent them was really allowed the companies now to say, okay, we can own this, not just, until the seeds get out into the world, but we can own this forever. And the patent itself, we can show our shareholders we have all of these patents. They themselves become valuable, not just the seed, but the intellectual property. And so
which is pretty crazy.
it's,
I mean,
yeah,
imagine if McDonald's patented a burger and you had to go to McDonald's to get that burger.
yeah,
Like, no, you can't make a burger at your house. No, you have to go buy this.
right. And no, it's crazy. And especially because, again, keeping in mind, if you look at like what the ancestor of corn or tomatoes looks like, it looks vastly different than what we're working with today. They're, small and not very edible and don't yield very much. And 99.9% of that work happened through, farmers, gardeners, stewards of the earth improving these seeds. And then that last 0.1%, that these companies do, they say, okay, we're going to put a patent on everything, all parts of this now. And so they've taken, they've this pyramid and they put the last little shiny, piece on the very top of it and say we own it all now, because we created this part.
That's how it works,
Yeah,
right?
and that's how it works. And so that's been a real tragedy, and something that OSA, and I'm less involved in that. Our policy side, Kiki Hubbard, who's our policy director, does a bunch of work trying to push back against this. I would say that, on that is kind of the doom and gloom. The positive side, I'd say, is that there's still, despite all of that, there's a real resurgence and growth of smaller seed companies, regionally adapted seed companies, farmers saving their own seed, public universities relearning their mandate of public service and developing and releasing varieties with fewer intellectual property restrictions. So it's not all going in that direction, but certainly when we look at where the biggest money is and we look globally, it's pretty bad.
Can you do me a favor? Just pull
Yeah.
that just a little bit close. Just
Yeah,
bring
yeah.
it in a little bit.
Yeah.
Perfect. That's always what I'd heard with. I think it's Monsanto. Do they
Mhm.
sell seeds?
Yeah, they've consolidated now. Monsanto has been bought by Bayer. So,
I remember that, that was a big
yeah.
buy.
Yeah.
I had read, I think it was a while ago, about seeds from one farm that had purchased them somehow ending up on another farm, maybe being blown over or something, and then Monsanto was trying to sue that other farm for their intellectual property because now they had their seeds, or they were crossbred or something weird like that, and they were trying to go after this farm because you didn't buy our seeds.
Yeah, there'd been a lot of legal back and forth as the companies had been trying to not just enforce their intellectual property, but also create fear around it so that people would be, yeah, would um, feel threatened by the potential of a lawsuit and be that much more careful.
Now, what is your stance on genetic engineering seeds, where you guys are the Organic Seed Alliance? Do you have a stance on that? Are you guys organic because you believe it's better or it's just more accessible?
Yeah, I think that what we feel is that organic and is the best label that we have in the sense that there are plenty of flaws in the organic certification process, and there are plenty of really great farmers and practices that are not part of the organic certification process and part of certified organic, kind of the certified organic industry or the certified organic community. That all being said, especially when we start to look at and so if I guess I would say, so if you're in a local community and you have a chance to go out to your farm and meet the farmer and talk to them and see how they're growing things and understand their practices, the certification that, whether you use the label organic or regenerative or naturally grown, that's not as important if you can have those direct connections, understand those practices. But for so much of our produce, it's so much of our food is we don't have a direct connection like that. It's being, shipped across the state or between states and processed. And so the certification process is, while it has lots of flaws, is really the most robust process that we have to ensure that the food is grown in a way that's um, you know, better, I would say, for the environment in a lot of ways. It's safer for the workers, it's safer for our health. And well, again, I think there's lots of exceptions there. You can say, well, there's a lot of tillage, a lot of turning over the ground in many organic farms that, is disrupting soil life or releasing, CO2. In general, when we look broadly across kind of the impacts of organic farms versus non-organic farms, we see that the environmental, the health benefits are improved, and that process is it also just gives you, again, if you don't have a chance to be able to actually meet your farmer, it gives you a certain degree of surety that you don't have, I mean, we see so many labels on our food products now, right? It says, it might say sugar free, and then it's like full of fat, or fat free and it's full of sugar, and then all of these, people slap many labels on there, and it's really confusing. And the organic label does mean something. It's backed by a pretty rigorous process that frankly can frustrate farmers sometimes by how much their fields and their books are looked over to make sure that they're doing things in accordance with what they agreed to do to be certified organic. The genetic engineering thing is a really interesting and question and debate. I think that I would say there's a few pieces there. Um, the f- the first is, I guess, basically it is part of the organic standard, and at this point, it's something that if someone's looking to be able to, for whatever reasons, would like to avoid genetically engineered food, there's an expectation that if they buy something organic, that is not genetically engineered. And so that label has, meant that since it very first was became official. And so that, is kind of part of the expectation of what it means at this point. So some of that is just the clarity of the label. The other pieces of kind of how genetic engineering and organic work together, um, I think that personally, the one of the big flaws in genetic engineering that you already have been alluding to is that it's been so tied up in corporate control. And that's because, in part, genetic engineering is a really expensive, it requires massive capital investment, um, and and it's tied up with being able to. One of the original motivations was being able to patent things, and so often genetic engineering helps encourage concentration in our seed industry, helps encourage more and more of the greater and greater share of our seed being controlled by these handful of companies. The other thing is that it's a tool, and so often where the tool has been used is been, if you kind of look at the products that the genetically engineered products that have been out on the market, some of the number one products have been ones that allow tolerance of herbicides and pesticides so that they can be sold as a package. It's developed in a package. There's not a coincidence that, Bayer or BASF, these big chemical companies are also the seed companies. It's because they can sell a package of seeds that can tolerate these chemicals plus the chemicals. And so you see, the original GMO material, is Roundup ready. You could put as much Roundup on there as you want, and the plants will survive it. And then as weeds began to, evolution caught up to Roundup, and you start to get these quote unquote super weeds that can also, through natural selection, right, not through genetic engineering, but through natural selection, weeds have now been able to evolve to tolerate Roundup. Well, now it comes with, 2,4-D, much more noxious herbicide, 2,4-D tolerant seeds. So now you can dump as much 2,4-D on your plants as you want, and the crop plants will survive. And it's, convenient that you can also buy those same chemicals from the same company that's selling you the seed, and they make, more money than if they had developed varieties that were, for example, more vigorous and able to outcompete the weeds, or able to yield well even in the face of weeds. So there's what I would say is that the genetic engineering is a tool, and the tool has been used in often cases not in the service necessarily of farmers or eaters, but in the service of this business plan.
The bottom line.
Yeah. Uh huh.
The
Yeah.
chemical aspect scares the shit out of me
Yeah.
when you start
Yeah.
talking about Roundup. I think I
Yeah.
read a study that I'm gonna throw this out there, people
Yeah.
fact check me on this, that 70% of Americans had Roundup in their urine. Andy, see if you can find that because I might have just made that up. But in in engineering these crops to be more resistant and then having to use more chemicals for the weeds or a different type of chemical, is that or is this just whack-a-mole? Are we just
Yeah.
going back and forth when the weeds adapt to that, then we'll create even harsher chemicals? I mean,
That's the worry. I mean, that's certainly the path we've been on, and it doesn't seem like, as far as anyone I talk to knows, that there's, that path is going to diverge. Yeah, it seems like because, yeah, first off, it's short term thinking. It's like, okay, we solved this for now, and also because, again, it's not like, although it's not good for the farmer's health, it's not good for the environment, it's not good for the eaters. Um, it is like those. Again, it's like the seed slash chemical companies are. It's a win win for them.
yeah, what do they care?
Uh-huh.
They're
Right.
selling the seeds and the
Right.
product.
Right.
Did you find anything on that?
Yeah, it says as of July 12th, 2022, more than 80% of Americans have a widely used herbicide lurking in their urine. A new government study suggests a chemical known as glyphosate
Glyphosate.
Mm-hmm.
is
Roundup.
probably carcinogenic to humans. The World Health Organization's International Agency for Research on Cancer has said, that's a mouthful, glyphosate is the active ingredient in Roundup, a well known weed killer.
80%.
Wow. Yeah.
That should scare the shit out of
Yeah.
people,
It's wild.
and it's just yeah,
Mhm.
Monsanto.
Mhm. Yeah.
So, when you do that, when you are engineering these plants to be more resistant to these herbicides and
Yeah.
pesticides, does that have any negative effect on the seeds or on the plant or on the food? Or it's pretty safe in that regard, it's just the aspect that now we're dumping more of those chemicals on the plant.
Yeah, I mean, that's been, another source of controversy, and I think that, um, one of the things, when part of the kind of, mm, just coincidence of all of these things, as the organic standard was originally being developed, genetic engineering was really brand new, and so, some of those I don't know if the organic standard was being developed today, honestly, how genetic engineering would fit in with that. I will say that, and there hasn't been, I would say, a lot of evidence that the genetic engineering process itself is necessarily risky. However, um, one of the things that it allows, again, as a tool, is that it allows for kind of more rapid and more, what's the word I'm looking for? More extreme uh, new traits to be brought into plants, and that never existed in those plants before, or maybe never even existed in the plant kingdom before, and and that can happen really relatively rapidly. The um, when we think about, like, for example, to dive into controversy, I mean, we have medicines that are, are products of genetic engineering that we've taken often, and and many people would be concerned about that. Those medicines, however, had to go through this extensive, and again, this opening up a controversial can of worms, but nonetheless, they did have to go through, you know, pre-human testing, phase one testing, phase two testing, testing on, thousands of people to see. Um, None of that exists for food products. And so you could, and this is always the worry, like you could very easily create um, there's this push around kind of like, um, you know, growing pharmaceutical products in your food. That this would be like a great way to be able to create medicine really cheaply. But that pollen, if it's something like corn, that pollen drifts around, and might go into something unintended. Those products, also the USDA process for regulating GMOs doesn't really, it has this it relies on company data, internal company data that says, yes, this is safe. And then they give this thing, they call it GRAS, generally recognized as safe. They say, yeah, we think this is safe. This is fine. And that's more or less the end of that safety testing. And so, regardless of how you might feel about, if genetic engineering is inherently safe or not, genetic engineering is a tool that can allow you to create things that we are going to be ingesting that could be just as risky as any pharmaceutical drug that you might take without going through the kind of process that drugs go through at all.
So there's no third party testing.
The-
It's all internal company data, and then they just hand it off and it gets the check mark.
In general, I think that there are processes where theoretically the USDA could step in, but as far as I know, that basically never happens. Yeah,
How crazy is that?
it's pretty crazy.
That's not exactly a comforting thought.
Right. And so that's why, again, for people, regardless of, whether you fundamentally feel like genetic engineering is just, a, um, a flawed technology that or if you feel like, well, maybe sometimes it could be good to add some more beta carotene into this food crop or whatever. Um, the fact that there isn't a safe, or there isn't a thorough vetting process for those products is one more reason why people might say, you know what, I just don't want to take a chance. And that's where, one reason why one appeal of organics for some people is to say, okay, I've got this label. I know that I don't have to, I'm not relying on the USDA's non testing. Yeah.
It's very uncomfortable hearing that. Do you I mean, that's, like, almost like going to Big Tobacco and saying, "Can you provide data on the effect of cigarettes? Are they
Mhm.
bad for people? I want you to do the data. You handle that and then let
Right.
me know."
Yep.
What would they come up with?
Right.
"No, it cures no,
Right.
cigarettes cure cancer.
Right.
You should
Right.
smoke a pack a day."
Right. Yep.
Do you think, in your opinion, I'm not sure how well versed you would be with this. Do you think that these companies are looking at long-term effects of what that those crops might have on the environment or on people, or it's all short-term, bottom line, bottom dollar viewpoint?
Guess I would say it's hard to know what their internal science is because they don't share
Yeah,
that.
obviously.
It seems like, I've, you know, having gone through I got my degrees and my graduate degrees in plant breeding and plant genetics and worked with people that, have now gone on to work at these companies and have some connection to some, have maintained some connections over the years. I would say that most of the time, what I hear is that the attitude is pretty, like, okay, how are we looking this quarter? How are we looking this year? There's a pretty strong focus on seeing, just like in so many corporate situations, seeing short term return on investment, wanting to um, avoid, certainly avoid liability, if at all possible, but not necessarily out of any kind of care for the world, but just in terms of how does that affect their bottom line.
Well, the whole foundation of what they stand on seems short-term, goal-oriented. We're gonna kinda screw up the environment with these pesticides, maybe with these seeds, as long as we hit that bottom dollar. There doesn't seem to be a long-term view established in that, like with a mom and pop farm where, okay, we live on this land, our kids are going to live on this land, our grandparents worked on this land. We need to ensure that it's healthy so it keeps producing.
Yeah. Yeah. Right. And I mean, that extends beyond just the genetic engineering, but it's also just the way that they do their breeding, their variety development in general is that though it's very hard to get access to this data because the companies, this is part of what's limited by their patents. The information we do have is that over time, if you think about individual farmers, let's go back 80 years where individual farmers were saving their own corn seed. Each of those farms, they kind of had their own variety. And so, and within each of those varieties, there was genetic diversity in that variety. And then between each farm, there's genetic diversity between those varieties on the other farms and scatter this across, you know, hundreds of thousands of farms on the United States as companies have consolidated, as a company has bought another company, and then that company in turn has been swallowed up by another, and again until we've gotten to like these big four. Each time that happens, what typically happens is that the companies will kind of think about it, they go through the seed list, and if company A had 100 varieties, company B had 100 varieties, they're not going to offer 200 varieties anymore. They're going to look and say, okay, what are the 100 most profitable across these two companies? Drop the ones that don't make the money, the ones that maybe are, adapted to a slightly less commercially important region, ones that maybe are a little more specialty, ones that maybe are thrive well in dry conditions, but not when you pump them full of um, fertilizer. Those varieties get dropped, and if nobody is around saving those seeds, those varieties get lost forever. And so, what we also see is that just first off, just by the very nature of corporate concentration in the seed industry and these business motives, we see this big loss in diversity. But also, even within each of those companies, there's such a short term focus that kind of the rule of plant breeding in these companies is what they say is they cross what they say elite by elite. They're very, very most productive variety by their next most productive variety. And they just keep on doing that again and again. And what you see is that these varieties become really, really genetically inbred, to the point where there's relatively almost no genetic diversity within the variety, almost no genetic diversity between the varieties. And I'm talking really mostly, like, to be honest, the vast majority of the money that is in seeds is going to be in, corn and soybeans, and then you see, some of the other big field crops, and then some, some of the vegetable crops, things like tomatoes and sweet corn. But the more money there is, the more it gets closer to this model of really, really limited genetic diversity. Just like, okay, we can't afford to fiddle around and, make crosses to diversify our genetics. We That's going to be slow. It might take years to like get up to the yields of our most elite varieties. And so they just keep on crossing essentially what are often like, functionally like, brother and sister, varieties that are already fairly genetically related. And so it gets more and more narrow. And this had been something there had been a crisis in the 70s where it was the southern corn leaf blight that had was a really minor disease, but because so much of the varieties were all so genetically related, they all were susceptible to this disease. And it had never been a problem before, but because everything was, basically genetically identical, it just like wiped out millions and millions of acres. And the companies kind of after that said, "Oh no, we're going to do a better job of stewarding our varieties genetics," but
Nothing's changed.
nothing's really changed. Yeah, it's fallen back to the same thing. So we're still at this sort of risk where, if a minor disease, a minor pest, this is part of the reason sometimes why we see these epidemics is because it's in a more natural system where okay, only 10% of the plants are super susceptible, and you know, and 80% of the plants are a little bit susceptible, and 10% of them are totally resistant. And there's this variation, like the pests can't establish themselves the same way as if it's like, oh, this is just this big field of
The same thing.
delicious, like easy to eat stuff that's all the same. And if a pest can thrive on one plant, it can thrive on 100 million plants.
That's the problem with bananas right now, right? Is the bananas that we think of as bananas are all just clones.
Right.
And there's some fungus, I think it's in South America right now. There's some fungus that is just tearing through it.
Yeah.
And they're having to burn the banana plant that's infected and then clear out some absurd radius around it and dig up the roots because they're cloned.
Right.
So if it spreads, it's gonna burn through like
Right.
wildfire because
Yeah.
there's no genetic diversity. It's all
Yeah.
the exact, literally the exact same thing.
Yep. Yeah. Same thing like with coffee. Yeah. So many of the clonal crops
I
are.
didn't know coffee was a clone.
Yeah, primarily. Yeah, they're very genetically similar. Yeah,
Doesn't seem like a smart business investment. So yeah, we're just gonna do the exact same thing and hope that nothing goes wrong.
right. I mean, it works. Again, it's a short-term thing. If you found something that's like, oh my gosh, this thing, yields 20% better than everything else, and you're and trying to maximize your short-term profit, trying to compete with your neighbor, you go with the thing that you say, okay, instead of saying, all right, we're going to do a little bit of the 20%, this quote unquote elite, highly productive variety. If you do a little bit and your neighbor does it all, and they yield better than you, and all of a sudden you're at a disadvantage. So yeah, it's hard without more um, public pressure in a lot of ways to push back against these perverse business incentives. It- it's unfortunately it's that our food system
Broken.
is broken.
Yeah.
Yeah,
I think that's the best way to put it
yeah,
is it's
yeah,
broken. Does
yeah.
it screw you guys over, their business practices for the organic seeds? Because if they're developing these crops that are resistant to these things, and then weeds and other things are adapting to that and getting stronger, is that screwing you guys over? Because now you're dealing with that as well, even though you were fine before before they came into the ecosystem?
Yeah, I mean, organic producers. There are several ways. Yeah, the conventional seed and food industry and farming industry makes it harder for organic. One is, like you said, this is breeding super pests, super weeds that then,
Spread.
yeah, then spread. Likewise, um, just the if you this is like this is now with the I was mentioning earlier, kind of the switch over from this Roundup Ready varieties to this 2,4-D, these 2,4-D ready varieties, these varieties that are able to tolerate this really. I mean, 2,4-D is kind of like a kind of part of the original Agent Orange mix. Like it's pretty um, uh, harsh chemical. Um, it drifts when people spray it, and so now farmers are buying 2,4-D ready seed, even if they're not planning on planting 2,4-D or not even planning on spraying it themselves, just because if they don't and their neighbor sprays it, all of a sudden they've got crop loss. Um, and if you're organic, that's not going to be the case. This is, I know, like a really great seed grower up in North Dakota, and it's just a huge challenge for her because they're surrounded on four sides by conventional growers, and there's always like I feel like every couple of years they have a big crop loss due to herbicide drift that comes into their non-GMO, non-herbicide tolerant crops.
Well, not to mention when it rains, you gotta think that some of that is getting washed off the
Right,
plants and off the topsoil,
right,
and it's going somewhere.
right,
It's not just staying
right,
on their
right,
parcel, it's moving.
right, right. And then the third piece is the seed companies. All of the investment that is happening is towards these really high these varieties that will yield well if they're given this, if they're part of this package, if they get the really high input fertilizer, they get the herbicides, they get the pesticides. And so if most of the seed varieties are out there are all being developed for those systems, then if an organic grower is planting those seeds and not using that system, those varieties, there's often this talk about a yield hit that you take when you're growing organic, that you're not going to yield as well as conventional, and um, some of that yield hit has been seen in, at least in some research in some situations, is really because of the seeds. It's when you're planting seeds that have been bred and adapted for these high input, chemically intensive conditions. And if you're growing them in non-chemically intensive conditions, they don't do that's not the environment they were bred for. And so when you're then able to breed and develop seeds for those conditions, you see that yield gap disappears to some degree. And so that's another piece of just as more and more these companies, you know, little seed companies that previously an organic grower might have been able to find the varieties that do really well for them. Well, now that seed company got bought up you know, by Bayer, and the varieties that were ones that would be profitable, that would yield high as part of this, Bayer seed package, are kept. And the ones that the organic growers maybe previously had relied on and had done well for them, those get dropped from the catalogs. And so this has been an ongoing struggle. Or varieties that previously were available non-GMO, those varieties are new and improved, and they add in the genetic engineered traits. They drop the older non-GMO one, and they say now, this is you know, there's like the temptation corn. Sweet corn is like this really popular sweet corn that a lot of organic growers wanted, but then they came out with temptation 2 now with, this GMO, genetically engineered gene stack on it. And everyone's just holding their breath waiting for the companies to drop the old non-GMO temptation, and then they're going to be out of luck.
How do they make these seeds more resistant to these chemicals? You know that process?
Yeah, so it depends. There's a lot of different ways. Some of this has become mm, this has really evolved pretty rapidly recently. So the technology is pretty leading. Like the previously, what it was in a lot of ways similar to in a traditional old fashioned plant breeding. What you might do is you would grow a bunch of, you'd screen, quote unquote screen. You try and find a whole. Let's say you're trying to find tomatoes that are resistant to late blight. You get, seeds from thousands of varieties of tomatoes, and also like tomato wild relatives, ones that are, you know, not necessarily the same species, but close enough that they sometimes can cross together. And you would, grow all of these, and then you'd, see which ones survive to late blight, and then you take those ones and you'd cross them to your best varieties and try and incorporate that late blight resistance into there. A similar kind of thing would happen with genetic engineering, but they would have it be a wider range of crops. So instead of just like if you're looking for tomatoes, instead of just with tomatoes and tomato wild relatives, you might look across all these different species. And then once they do that, then they go through more of a investigation process where they try and isolate down what gene was it. Let's say instead of in tomatoes, you found it in um, I don't know, in plantains or something. The wild, not plantains in the sense of the banana relative, but like with the wild plantain that you'd see around here. Just as an example, let's say you saw it in there, and then they go through a process of saying, what's the gene in here that is causing that resistance? So there's different kind of genetic studies that you can do to try and figure out what gene, when that gene is there, the plants are resistant. When it's not there, it isn't. Once they've identified that gene, then they go through this process where they will try and basically move that gene from the donor plant into the recipient. And usually that involves some methods of slicing out that gene, incorporating it into a bacteria and a virus, and then using that to kind of infect the recipient plant, and then um, that phage, that virus will infect and basically incorporate the DNA into the plant. And then from there, once they've got it in the plant, then they can, it's usually not as simple as that. You have to try lots of times and it may or may not work. And it depends on where the gene gets incorporated. It might break other important genes when it gets incorporated. But once they try enough, then they find it and, okay, we've moved the gene. Um, and then they can start reproducing the seed. Um, in more recent times, there's a little more of that happens kind of where we're starting to have a better sense of like exactly how proteins interact together, in chemical ways. And so there's more of this kind of actual synthesis of new genes rather than just, the older GMO technology was more just being able to kind of broaden the pool of potential species that you could move genes between. And now there's more of a move towards being able to say, okay, based on what we think, the kind of protein that we think we need this gene to make, what is the DNA code that we need in order to make that protein? So sort of reverse engineer that, and then they can actually, using some of these new technologies, like there's something called CRISPR, they can actually, individually kind of, nucleotide by nucleotide modify and match what they think, the DNA needs to be in order to make the proteins that they think will work. And then they say, okay, and then they test and see, does it work?
And they'd be able to use CRISPR on plant genetics?
Mm-hmm.
That's insane.
Yeah. Yeah. I mean, that's definitely the future and even the present. Yeah.
It's fascinating in the sense that people were so afraid with the emergence of CRISPR and that we'd be creating these superhumans.
Yeah.
And what would that do to society and, what's going to happen? But it sounds like we've been doing that with these GMOs is we're kind of playing God in a sense of just throwing shit at the wall and seeing what sticks. And no,
Yeah.
it doesn't sound like there's any oversight as to somebody steering the car, looking down the road, saying, "Oh, there's a turn. We should watch out for that." It sounds like we're just going.
Not a lot of oversight. No.
Is that because people are just unaware, or they don't know, or the farmers don't have a big enough voice to say, "Hey, we need to start turning the ship." Why is that it's just this progressive march down this path?
It's a good question. I don't know. I feel like my cynical side says that, a big part of this is just that big agribusiness and big seed they have good lobbyists and they have a lot of, there's a lot of revolving door between, the USDA regulatory system and these seed companies, people coming from the seed companies into the USDA and then back again. Things like that where um, the relationships are pretty cozy and Yeah, and there's not necessarily a ton of public pressure against it. The big, um, as of now, the big farming interest groups, the big corn growers associations and stuff like that, they're not pushing back. I mean, in some ways they are, sometimes with like the exorbitant seed prices or things like that. But in general, they're, happy to get higher yields every year. We haven't had a um, crisis like the northern corn or the southern corn leaf blight since the 70s. And so, kind of like one of these things where, until it happens, we just keep on moving, pushing forward down what seems like a pretty risky direction.
If that happened today with corn or with soy,
Yeah.
it sounds like it would get pretty bad.
Again, what's different between the 70s and now is we have less data about how incredibly genetically uniform it is. But to the best of people's understanding, yeah, it'd probably be worse that we have more genetic uniformity across more acreage. So, yeah, I think we're more at risk now than we were then, probably.
That's not good.
No.
But again, it feels like this is just the progression that is happening, that it doesn't seem like there's any. I mean, can you turn the ship? Can we Is there a way to revert back, or do we just keep going down until we have something like that in the '70s? And then maybe it shakes us, or maybe we just keep going further. I mean, does it stop? Do GMOs become the norm? Because if all of these chemicals or these weeds are spreading out and are in surrounding areas, are we going to hit a point where it's not feasible to use organic seeds just because the viability won't be there, the crop yield will become so diminished that it won't work?
I guess what I would say twofold. One is I mean, despite all this doom and gloom, there are a lot of, on the policy side, on the politics side, there are a lot of people that are pushing really hard against all of these issues, against the industry concentration, pushing for better safety regulations. And there's more, I guess, receptivity in the current administration than there was in the last, for example. And there are good people in the administration. There are good people in the Department of Agriculture, and there is probably more pressure now than there has been in the past. And there's more scientific evidence building around these risks. So, how ultimately how well that pressure results in actual change, I don't know. It's hard
Hard to say.
it's hard to say, but to your other question about what does that mean for organic farmers, one of the things that you see with good organic farming practices often is that the the many of the kind of most successful organic farmers, they don't tend to use silver bullets. They often aren't relying on a single tool to manage their weeds, for example. They might be basing this on, strategic timing of their planting, of growing varieties that are vigorous, of different tools for managing, mechanically managing their weeds, reducing the weed seed bank. They're often attacking any problem on their farm from several different angles, and that, it is potentially slightly can be harder, especially for people that are just getting into it. It's a more robust system, and so compared to, yeah, just spraying and then saying, "Oh man, my spray isn't working anymore. Where's my new spray?" If you've got, five different approaches that are kind of weaved together to attack the same problem, as one, becomes less effective, you can still lean on the others. And so I think that's that resilience that you can see in a lot of, experienced successful organic farms is, in fact, something that one of the nice things is that something that is can actually be a positive influence on agriculture more generally, where some of those tools and techniques you start to see, for example, in the Midwest, there's this big boom in growing cover crops and growing, crops over the winter time to foster the soil in conventional growers. A lot of that, so much of the research and development and perfection of like what varieties of cover crops, when to plant them, when to plow them down, was done by organic producers. And as that's being refined, like conventional non-organic producers are, seeing the benefits of this and starting to incorporate it in themselves. Or like I had this example where there was a spinach grower um, down in Central California who was a split operation, conventionally and organic, and he, in his organic spinach, had started to experiment with this garlic extract to control um, mildew on his spinach, and he developed and it was successful and basically replaced the chemicals he'd been using to control it on his conventional acreage with this garlic extract, and kind of was able to carry that knowledge forward. And so I think you see that there's a lot of really innovative solutions that organic growers do, and that both, though I think your point is really well taken, that it's there's a lot that organic farming and farmers are a lot of challenges that they're faced with, and those challenges aren't necessarily getting any better. That there is this uh, ingenuity that you see and this multifaceted approach to farming that is something that helps give them both resilience, but also hopefully will, benefit agriculture more broadly.
Can organic farmers compete at scale with large scale industrial grows that use chemicals? With solutions like that garlic that you mentioned? Would they be able to feasibly do something at that size? We're
Well,
talking like a large farm. I don't know how big a
right,
large farm would
right,
be,
yeah,
10,000 acres or
right,
something.
right. Like, so for example, that spinach grower, he grew, I think he was growing maybe like, I get, boy, it's been a little while, so I'm trying to remember the exact numbers, but it's somewhere around 6,000 acres of conventional and 2,000 of organic. And then he started applying that to all of his organic, all of his conventional. For many growers, I think that as you scale up, it becomes, um, it becomes harder, not necessarily to grow certified organic produce, but it can be harder to incorporate all of the really innovative techniques and technologies. And you often see, you know, and I don't know. I mean, I'm just speculating why this might be. Some of it may also just be kind of the nature of who's growing at that scale. When you start talking about really large scale organic, it's often going to be people that are coming out of large scale conventional, or it's even a split operation. Del Monte, is going to grow conventional and organic, and so they will have, they'll follow the letter of the law for what you need to do or not do for organic, but they're often still coming from the farm managers that they're bringing on, and the people who are in charge of how this operation is going to go are often coming from it, having absorbed really the perspective of the large scale conventional farms, and so they're a little less likely to kind of go quote unquote above and beyond the bare minimum of what the organic standard requires.
Yeah, why spend more money?
Right,
Just a little bit more money to do it this other way where you
right,
don't need these things.
right,
If well, let's just buy the chemicals and save a couple bucks.
right,
I guess you would need that incentive to be there or
right.
support.
Right. Yeah, exactly. Yeah, because there's often sort of this. I mean, and again, I think it's still, you're still, as especially as a consumer, and also as like thinking about the farm workers that are usually not, there's not a lot of thought for them. I mean, they're the ones at the front line getting the impacts of these chemicals much more than we are eating the food. They're the ones that are getting flown over by crop dusters. But um, that the organic is, even the kind of the bare minimum of organic is a vast improvement for them, in terms of what they're not getting sprayed with. But there's kind of this maybe slightly derogatory term called input substitution organic, where it's like, okay, you're not spraying, the um, you're not perhaps you're not spraying a really noxious pesticide. So instead, you're like, okay, what's the pesticide that's the organic certified pesticide, and I can just pour that in the tank instead of this, But otherwise, our farming practices are still really similar, um, and so you get some benefits, but not the same as if you're really trying to think about caring for the land that you're growing on.
Are organic pesticides any better? Or is it I mean, it still has pesticide in the name.
Yeah, I mean, I think it depends on the. I mean, I would say in general, yes, but yeah, it's still often,
Yeah,
and
anything that's not derived from Agent Orange is probably a step in the right direction,
right,
right?
right. Yeah, yeah. I mean, I'd say, yeah, the short answer is yes, but I would, yeah, there are plenty of those that you're still not wanting to ingest or get sprayed
It's
on.
still
Yeah,
not ideal.
right.
It's
Still
not
not
the
ideal.
way that we would wanna be moving.
Right.
My understanding is that soy and corn are largely subsidized by the government, right?
Hmm.
Do you think that would be one alternative for organic farming is maybe work in some government subsidized formula where that would incentivize people to start to switch back to that as a way to counteract the direction we're going? Or would that not be feasible with how far with where we are?
I, I, again, not being a policy expert, my best understanding is, yeah, so much of our agriculture, again, we don't see it as much here, but if you go to the Midwest and the Great Plains and some of the biggest agricultural places in our country, that landscape that you see of corn and soybeans or corn and more corn is really so strongly shaped by our federal policy. Yeah, it's shaped by the way that our we have these you know subsidies and insurance products and all of these things that make it so that you're basically, yeah, guaranteed to make money if you grow these crops because the government's going to pay you if you don't make enough. And that model, not just for organic, but just if there were more crops, like if it instead of it just being corn and soybeans, if it was like corn, soybeans, alfalfa, wheat, like if it was like six crops, all of a sudden you'd have a much healthier, more diverse landscape than we have. There'd be better, what we call crop rotations, where you're cycling through these different crops and avoiding some of these pest problems, avoiding some of the problems with runoff with these, annual these crops that are grown on a 1 year cycle, versus things that are more perennial that can develop roots in the ground. So yes, if organic had even somewhat more of a level playing field, like organic, it's a huge struggle for a diverse organic farm to get insurance for crop loss. What's something that's very, very easy if you're just growing. I mean, I shouldn't say very, very easy because I've never had to, you know, apply for insurance for 10,000 acres of corn, but something that's a straightforward process that many people do every year, um, is really way more onerous, way more tricky for someone that's growing a lot of small amounts of crops. The products, the insurance products that the government offers, even outside of just subsidies, that the insurance is subsidized, so it is a form of subsidy. Um, just don't really apply to the kind, to diverse organic farms. And if we want to encourage not just organics, but if we want to encourage just diverse farming practices, changing the way that those incentives work would, to the best of my knowledge and what I've heard from many people, would be like one of the single biggest things.
Well, yeah, and especially with the insurance aspect, that just incentivizes you to go conventional. Why be organic if I'm gonna have to pay more insurance and it's just gonna cut into my profit margin?
Right. Right. Yeah, right. I mean, yeah, with a lot of the conventional growing, it's like it's just it's just win-win. It's like okay, you have a crop loss, but you still make money. Maybe not as much, versus, yeah, you have a good crop year. It also creates like a situation where farmers are really willing to take risks, to do things that, again, like we're talking about, like it's one more reason why these really, really kind of high yielding but maybe fragile varieties like these corns that might be really disease susceptible, and might completely fall flat. And you see this, just um, die in a bad year, the disease or if it was a drought or whatever. But in a good year, they just go gangbusters. It's that kind of gambling is encouraged by the fact that even if they have a total crop failure, they're going to get paid by the government. Whereas for organics, that it's not like that. Yeah, if you have a crop failure, maybe you're you know losing money this year. Maybe you can't keep the farm. Maybe you can't pay yourself. Maybe you're taking on more debt to get another season in.
Or you're
Yeah,
selling your farm to
right,
another big
right.
aggregate.
Right. Right. Well, and then this is, I mean, so the systems are so crushing because then what happens when you've got something that's a guaranteed profit, the way that the these large conventional commodity crops are, is that now that means that the what's the limiting factor? It's how much land you have, and so now land prices go up to reflect the fact that this land can guarantee you a profit. And investment firms come in and buy these large tracts of farmland based on the knowledge that this is, a guaranteed profit. And so now the people who are not part of that game, who are trying to grow organically, now their land costs are going up, and so they can't necessarily buy into a farm, or their leases each year now are higher than they were before, and so that's not only are they not benefiting from the system of insurance, but they're kind of actively being hurt by it because it's everybody else's, the prices are reflective of the fact that everybody else can get this guaranteed money.
So not to get too depressing,
Yeah.
but it feels like if you're going organic, you're going against the current. The system is almost set up to make you switch. You almost have to want to believe. It's almost more of a faith-based thing that you believe organic is the way to do it, that it's better for the land because it is, and you're going to ride that out. Because why else would you do it? Why not switch conventional? The money is there, the insurance is there, you can get the seeds, less variability, less risk in some regard. I mean, why stay organic?
Yeah. I mean, I think there's a lot of reasons that people make those decisions. I think that for, you know, big companies that feel um, confident enough in getting a premium price, and accessing the organic market that's been growing and it's continued to grow. It's one of the fastest growing kind of food product segments around. There are financial interest even at that large scale in you know taking that chance to be able to get that organic premium price to be able to get into that market. Um, but at a farm scale, I would say that talking to people who have, a good perspective is people who have made that transition from conventional to organic production. And you hear people say that it's, uh, yeah, one is kind of this feeling of as for themselves, like, I don't want to, if they live on the farm, I don't want to, be drinking poisoned well water. I don't want to worry about my grandkids getting, sprayed. Uh, but also this for a lot of farmers, again, kind of, and this is not like here on the North Coast. We're talking about much smaller farms where they're diverse, where whether you're conventional or organic, often you know, you're having to be creative in how you're growing, how you're marketing, how you're making a living growing. But somewhere where there's this sort of more set path of what it means to run a farm in big ag land, and whether it's in uh, in the Central Valley of California, or if it's in, the big field crop acreage of the Midwest, that what you hear sometimes is that farmers feel like they were, everything was so prescribed that they were, this is the seed you grow. This is when you spray. This is, the tractor that you're buying and the planting distance that you're doing and when you're harvesting. And here's your buyer. And it's like they're just very much sort of this cog in the machine, just um, with organic. A lot of the farmers that I've heard have said kind of these similar things of they felt like they were a farmer again. They were making decisions. They were actively shaping. what crops they were growing, how they were growing them. They were experimenting and innovating and excited about the practice of farming in a way that they hadn't been when they were on the conventional side. So just as a, so there's that health side, and then there's the kind of that lifestyle of, what are you what are you doing with your life? And if you feel like uh, you're not actually farming, you're just, operating a tractor following the guidelines that have been handed to you. um, that's something that I think people really have enjoyed. But yeah, I think that the risks, like you said, the financial risks are real. And I mean, and to be fair, I mean, organic or conventional farming is a hard and risky job, for, and being a farm worker is, grueling work. And that just is general in our society. Like, I don't think there's a lot of value placed on what that means. We don't, general people are not being that the money that's being generated in our agricultural system is so rarely going to the farmers and farm workers that are doing the work. Often that money is captured at the wholesale processor level. um, and so that applies kind of across the board,
Well, people today are so disconnected from their food
right?
because the level of abstraction is just so great at this point. I mean, how many people actually know people that even grow their own food anymore?
Right,
Just, oh, I'm going to the supermarket. There's my food.
right, right, right. Yeah, and we have expectations about what things should cost. And I mean, to be fair, I mean, people struggle. And I mean, it's hard when food is expensive. I don't know that it's, you know, I don't fully, agree with kind of, well, we all just need to pay more for food, because I know it's not, that's easy to say when you have plenty of money, and it's not easy when you're scraping by and trying to feed your family. So I recognize that. But it's not, yeah, like I said, I think that there's a space where you can both where farmers and farm workers can be making a living that reflects the amount of work that they're putting into it, and that we're still able to eat healthy and eat affordably. And frankly, a lot of that is around kind of where is the money being pulled out of the system, and it's often these.
Everybody wants their cut.
Mm-hmm,
Everybody's trying to squeeze in
uh-huh,
whatever they can. That's the
yeah,
problem.
right, right.
Topsoil is
Mhm.
another aspect of this problem, right? Isn't the topsoil, especially in America, isn't it pretty shitty right now?
I mean, soil is, and again, I have to get a
We're kind
soil,
of
yeah,
yeah, diving into different areas.
get a soil expert to give you the details. But yeah, we are essentially, I mean, soil grows extremely slowly in general. The generation of this, we as a country and have this incredible resource of our soils. It's probably one of the things that's, you know, allowed America to be such an agricultural, power, is because of having these, rich, deep soils that took, thousands, tens of thousands, millions of years, depending on where it was, to develop. That is basically being mined. The nutrients in the soil itself, are being lost way faster than they naturally replenish themselves. And so it's huge risk. We kind of say, okay, well, you're just, well, sure, you can just grow the crops, wherever there's a flat piece of ground. Well, really, the way that we currently grow our food, it relies on this resource that's been built up over all of this long time that really doesn't get a lot of respect.
And does rotating crops help with that?
Yeah, so some of the, I mean, there are a lot of different things that can help with that. One of them is, yeah, rotating crops, especially including more perennial crops in your rotations, things that last for more than 1 year, that can develop roots that hold the soil in place, that actually kind of help build the soil, because soil is ultimately formed from the minerals below, in the bedrock, and in the kind of, these deeper parts of the more minerally parts of the soil, combined with the organic matter that comes from the plants and from the roots and from the microbes that feed on those roots. And so, perennial crops with their more robust rooting both protect the soil but also add to the soil. So having rotations, having just good conservation practices where you think about, maybe you shouldn't, till your soil on a steep hill, parallel to the hill right before a rain, or before, wind, thinking about, how do you actually minimize the amount of tillage you're doing and be smart about it. Create, instead of just a single slope down a hill, creating terraces where you are minimizing the amount of runoff that can happen. Maybe if there's any amount of water running, it just has to go for a little while before it hits another flat terrace and slows itself down. How do you kind of slow down the speed of the water, allow it to infiltrate back into the ground instead of running off along the surface? Yeah, there's a lot of good strategies, and these are things that are not organic specific by any means, but it's another place where you have seen a lot of the innovation come from organic farming and kind of transfer over more and more to the broader world.
which is not a bad thing.
No.
Innovation is always, I mean, innovation, especially if we could swing it more towards the organic side. It sounds like that's really what we need. And to bring the cost down. I
Hmm.
think if the cost came down and people realized, oh, it's competitive, we could buy organic and it's not going to break the bank. We don't have to support monocrop agriculture or go eat this pesticide ridden food. We could do this. Feasibly we could do this. I mean that's it
Hmm.
feels like that's the
Hmm.
direction we need to go in.
Yeah.
Well, this was a scary conversation for me. I'm
Yeah.
kinda it confirmed some things and it
Uh-huh.
freaked me out a little bit, but I'm happy to know that organizations like the one that you work for, Organic Sea Alliance, that you guys are out there and you guys are kind of fighting the good fight, helping farmers and showing that there is a viable way to do this.
Yeah, I mean, I think thank you. I think that a lot of what we do is recognizing and in support that it is the farmers, it is the seed growers and seed savers that are doing the work, that is not just doing the work of, growing our food that we need or the seeds that we need, but also doing the work of building the path forward of like we talked about, doing these innovations, developing new varieties that might be more resistant to, climate change, developing varieties that are more nutrient dense, developing varieties that are resistant to diseases in more robust ways than a lot of the big companies. And so our work is in support of that often. So being able to bring to, uh, help new seed growers be able to break into this livelihood, helping connect them to, equipment and resources and information, helping connect them to each other so that people can learn from each other and can also kind of build community and strategize together. So I've felt really fortunate in all my time working with Organic Seed Alliance just to be able to work with some really passionate, hardworking, innovative, brilliant seed growers, and that's why I do this work.
I really do like the aspect where you guys are almost open source in that sense with seeds. You guys aren't trying to patent anything, you're not trying to hoard the information that you're gathering. It's no, we're gonna save seeds and we're gonna help you make whatever seeds you need that would be best for your land. Like that's what we're here for, and we're going to share that knowledge. I think more avenues that embrace that is a good thing.
I 100% agree.
Okay, well, Jared, this was great, man. I really appreciate you coming on.
Yeah, thanks for having me.
Absolutely. Do you want to plug Organic Seed Alliance where people can find that, where they can find you, maybe if they want to get involved?
Yes. So if you want to learn anything about seed growing, about seed selection and plant breeding, about some of these issues around seed policy, seedalliance.org is our website. We have hundreds of publications, webinar recordings. We often are participating in different workshops at conferences. I'll be down at the Ecological Farming Conference guess next month, as well as we have a California Seed Summit next month, be the California Small Farms Conference and the Oregon Small Farms Conference next month. And then locally here in Humboldt County, you can feel free to get in touch with me. My email is jared@seedalliance.org. And we have trials and uh, typically we've been partnering with College of the Redwoods Farm down in Shively, and if you ever want, we'll do tours and field days each year. So if you go to our website, and you can either email me or sign up for our newsletter, and you'll get informed about when those are happening, or feel free to, yeah, just get in touch, and I'll be happy to give you a tour anytime. If you're interested in checking out local seed excitement, the Humboldt Permaculture Guild is having their seed and plant exchange in March. It's always a fun activity, and this will be a chance for you to be able to. We'll be bringing a bunch of seeds that we grew, and some of the other local seed farmers and growers have seeds that they're sharing of locally adapted varieties. So it's a great place to meet other people. If you're here in Humboldt County, if you want to be able to connect to other seedy folks.
All right. Well, Jared, thanks.
Thank you.